What? Okay, we're going to come together as a class. We're going to come together as a class. And I want to focus first on our graphical ones, number 1 and 2. Now, I think that a lot of you are finding it a little bit easier to look at number 2 first and see if that rule could apply to number 1. Okay, so Amy, you're shaking your head like really excitedly. What? Okay, what did you figure out was number 2? Like, how did you 1 and 5 and oh, like, could you describe that a little bit more? What do you mean, like the distance? Okay, so like this, what's our horizontal distance right here? 5. And what's our vertical distance?
1.
Oh my God, it's a fit. Okay, so let's do that up here. What's our horizontal distance? What's our horizontal distance? What's our vertical distance? Try that again. Over here we did. Over here we did 1 over 5. Over here we would have to do 4 over 2. 2. Okay. Now, how do we get the fact that like this one's positive and this one's negative? Raise your hand, Sophia. So this one's like rising while this one's falling? Yeah. Oh, okay. Okay. So now let's look at number 3 and 4. Abby.
So when you print the number 3
Quiet.
and 4, and you can look at it and see like how much are they adding and how much they are subtracting. I know that because that's always adding 1, x is always adding 1, and then y is always adding -2. So
Subtracting 2 or adding -2. Either way is fine.
and then yeah, you can tell it's one work because y is adding 1 every time, and 4 for x is always adding 4.
Okay. So these ones that are fractions, obviously there's like some x's and y's that matter, right? These ones that are fractions, what goes in the numerator, the x's or the y's?
X is numerator, y is denominator.
So look at the 1/5.
The y.
Vertical is vertical is y, right? Vertical is up and down. Vertical is up and down. So here we have vertical over horizontal. Vertical over horizontal. Vertical over horizontal. Vertical over horizontal. Oh my gosh, I think we have a rule. Turn in your student journal to page 81. Okay, here we go. Slope. Slope we're gonna name with the letter M. Okay, I'm gonna call it rise over run, which is really just the change in our vertical over the change in our horizontal. Rise like an elevator, run on the track. Okay.
Skydiver.
Run like a skydiver. Okay, you are not going to run vertically. Yeah, if you have like the sticky feet, like Spider-Man, maybe. Okay, so now. Listen to me. Listen to me. Okay. If you were to, well, let's go to the next page real quick. Okay. You've already told me that positive slope is going to rise and negative slope is going to fall. What I want you to understand that zero slope is horizontal and undefined slope is vertical. Now, let's talk about this. I want you to imagine a skier. If a skier was on a positive slope,
He would go back.
well, he would have to work really hard. Puff, puff, positive. He would have to work really hard to use his ski poles, right? Okay. Now, how is this skier going to feel about the negative slope? He's going to be zooming. He's going to say, nice. This is nice. I am getting really frustrated with the amount of side conversations. A slope of 0. Technically, could he ski on this? Yeah. Cross country ski. Okay. Technically, could our skier ski on this guy? No. No. Okay. This would not be okay, which is why our slope is undefined. This skier man would be undefined. Okay. 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 He's not okay.
It's like a roller
Couldn't it just go the other way?
Okay. Oh, Preston asked, could it go the other way? Is it always going right? We always read our graphs from left to right, just like we do words. Okay, so we're always going to read our graphs from left to right. Okay. So I want you to look at that next page. Do you see how there's this right here? This number 1. We have a vertical line. And what would happen to our skier man? Okay. So this would be undefined slope. Okay, our slope would be undefined. Now, on this graph right here, I want you to draw the rise. I want you to draw the run. Of number 2. Draw the rise, draw the run. Draw the rise, draw the run. Well, I'm going to rise before I run because that's how slope is calculated. That's fine, but you got to remember to put the rise first in your, okay. So Amy, how far did I rise up? Amy has a lot of voices. That's amazing. Okay. Carter, how far did I run? 4.
I kind of have it like this.
It could have, but we have to put the rise over the run. You still get the same numbers, but the rise needs to go over the run. We have to, like, because we have to do.
Okay.
Okay. Okay. So what's 8 divided by 4?
Yeah.
Okay. Now I need eyes up here. Eyes up here. Eyes up here. Still waiting for you. We don't need whiteboards right now. They can be put away. Now, how efficient is it to graph every single set of points that I give you? It is not going to be very efficient. So I want us to look at this right here. And I want to think about how could we have gotten 8 for our rise without looking at the graph? Like, is there a way to just look at my coordinates and get 8?
So basically, all you have to do is you look at your coordinates, and then what you do is you look at where 0 is.
So we're not on the graph. I'm just looking at coordinates, not on the graph.
Well, you can count up like how many does it take to go up? Like -1 that would be 4, and then -4 that would be 8 to do.
Okay, so how do I like mathematically figure out the distance, but hold on. The distance between -4 and 4.
You add. You add.
Okay, -4 plus 4 is 0. I don't think adding's the right thing because I should not get 0. Oh, I need to subtract them. Okay, so we're gonna go back to our notes here. Turn back to here. If we do not have a graph, then we are gonna calculate slope, still rise over run. But for my rise, we are going to take the difference of our y's. That'll give us our rise. For our run, how do I figure out this distance? Well, we can take the difference of our x's, and that will give us how long our run is.
3 miles.
What is this?
Hold on. Peyton, Maddie, Gus, Abby, Anna. I had a question. What do those 2's and 1's mean? Okay. I have two different coordinates right here. I just named this coordinate 1 and I named this coordinate 2. So the reason I did that is because, do you see how both the x and y from the 2 are together? It is important that if you take the y from this coordinate first, you have to also take the x from this coordinate first. It doesn't matter which one's x1, y1, and which one's x2, y2. I don't care which one's your first and your second coordinate, but these two better come from the same coordinate, and these two better come from the same coordinate. Are you with me? So let's go back to those problems, please. Okay, we already know that the answer to this is 8. And it's when I give you a graph, man, is calculating the slope nice. But if I don't give you a graph, let's talk about how to do it without graphing it, okay? So in red here, we are going to calculate our rise by taking the y coordinate minus the y coordinate. So I took y coordinate minus y coordinate. I am now, for the run, gonna take x coordinate minus x coordinate. Four minus -4. What does that mean? That really means 4 plus 4. And 3 minus -1 really means 3 plus 1. Oh my gosh, I get 8 over 4. which is 2. That is an excellent question, Peyton. Do we leave it as a fraction or do we simplify it? Okay. Simplify it. Now, sometimes your fraction is going to need to be simplified, but it's still going to be a fraction. Okay. A lot of times our slope is going to be a fraction. Okay. Now, I want to come over here to this one, number 1. We already know that our slope is undefined. Let's talk about what happens if we don't have the graph and we only have the coordinates. Okay. Okay, so I already forgot. I don't know how to say this stuff.
I don't either. It's all right. We don't need to.
Okay.
No, we can skip this.
Oh, okay. We have rise over run. Good. Is rise the x's or the y's?
Why?
Oh, the rise are the y's. Okay. So, Peyton, what do I need to do with my y coordinates?
You need to put the coordinate minus the other.
Oh, I take my y minus the other y. Cool. And then my run are my x's, right?
You run away from the
Sure. Yes. Sophia, since I wrote 4 minus -4, what order do I need to go in for my x's? Which coordinate do I need to pick first, the top or the bottom one? Sophia's answering this. The top. Since the +4 came from the top, I need to choose this 3 minus this x coordinate. So we get 8 in the numerator, right? Abby, can we divide by 0? No. Which is why our slope is undefined. We cannot divide by 0.
Yeah.
What's question?
What do you think? It isn't really everything fixed to the top or the bottom.
Right. Right. Yeah. Okay. I would like you to find me the slope for number 3 using rise over run and then use the formula and make sure you get the same answer. You are finding me number 3. Use rise over run, then use the formula. You should be getting the same answers. Like you did this, is that what you're saying?
Yeah.
Okay, so Peyton already thinks he has the answer right. Peyton, what slope did you get? What slope did you get? Hey, is our skier gonna say, imagine there's a skier on there. Is he gonna be working hard or is he gonna be like, nah? So what kind of slope is this? It's a negative slope. Okay. Now you could have calculated your slope two different ways with our formula. You could have said 3 minus -2 over -2 minus 3. Or you could have said -2 minus 3 over 3 minus -2. Okay. Here I take this coordinate first. Here I take this coordinate first. Guess what? It doesn't matter because we still -1 either way. You just need to make sure that if you choose this 3 first to start with, then you choose this -2 first to start with for your x's. Do you see what I'm saying there? Okay. This coordinate is right here or right here. I don't know why you're trying to leave because we still have a minute and a half. Do you have a question? Not really. Not really means you sort of have one.
I'm gonna cry.
No? Or are you gonna cry?
'Cause this is-
We'll be okay. Okay, your homework is from the book. Yes, my dear. Okay, Sophia asked an excellent question that I think you all should hear the answer to. If there's a graph, can we count rise over run or do we have to do the formula? What do you think? Which one's gonna be quicker?
Rise over run.
No, the like counting one.
So I'm okay with you counting rise over run because I think it would be more efficient and less room for error. But if I give you 2 points and not a graph, don't graph them because that's going to waste a lot of time. You see what I'm saying there?